So when we talk about solving an inequality, and that is the core skill in the third module of our course, is taking an inequality which describes the range that a variable might take and discovering from that inequality what's the simplest way to phrase that restriction on the variable, which is equivalent to the inequality that we start with. But in addition to the process of solving, which is where we're going to start, I also want to think about the mode of communication of our answer. So how do we describe that subset of the real number line, which is described by an inequality in a variety of ways? So not just describing it as an inequality, as we'll do at the bottom of the screen here, but also thinking about a visual representation of it as a graph. In other words, showing it as a subset of a number line, which we've drawn as a visual, stretching from left to right on the page. And then also, and this is the one that I can practically guarantee is going to cause you the most headaches in this module, thinking about how to phrase your answer as an interval. It's not particularly challenging, but it's probably also something that you haven't had a lot of experience with in the past. So 2 steps. We want to talk about the process of solving an inequality, and then we want to talk about the process of communicating that answer in a variety of ways. So let's start with our first inequality on the left. 8 is greater than or equal to 5v minus 22. How did you solve this inequality to discover what v must be based on this inequality? Where did you start? What was your first step, your opening move? Added 22 on both sides. So the good news about solving inequalities is that most of the steps are no different than the corresponding steps for solving an equation. So we can, if we want to, suspend disbelief for a moment and just put an equal sign here and pretend that this is an equation. If you do that, then almost all the steps after that are completely the same as what you would do if this were an equation. So here, add 22 to both sides. That'll give you 30 on the left-hand side, 5v on the right-hand side, and then what?
Then I divided by 5.
Divided by 5, because 5v is 5 multiplied by v, and dividing by 5 will get rid of the 5 attached to the v. And that will leave me on the right-hand side with v. It'll leave me on the left-hand side with 30 divided by 5, which is 6. And then, if I'm pretending that there was an equal sign there in the first place, I would have gotten v equals 6. And that's great, but we changed the problem when we changed the inequality sign to an equal sign. So let's go back and retrace that. So we started out with this inequality sign, which points to the right. So we're reading this inequality sign. How do you read this sign in English? Greater than or equal to, right? We always say that the inequality sign is like an alligator that wants to eat the bigger quantity. So this gator is eating the 8. And so 8 is the bigger quantity between 8 and 5v minus 22. So 8 is greater than, and the line underneath it indicates may also be equal to 5v minus 22. So if we restore that inequality sign along the way, then this is what our work ends up looking like. 6 is greater than or equal to v. That's a little bit of a clumsy way to state our answer. I'm probably going to want to try and rearrange this inequality at the end so that v is the subject of the inequality, that which comes first in the sentence, as opposed to that which comes second. So is there a way I could rewrite this to put v on the left side?
You could put v and then is greater than or equal to 6.
V is, so how would I write that? V is like this?
No, other way.
Other way. Right. So if I'm going to flip-flop, this is the first difference between inequalities and equations. Equations, we can just switch which is on the left side of the equal sign, which is on the right-hand side of the equal sign, without changing anything else. Inequalities don't work that way. If we switch the left and right-hand sides, we also have to flip the inequality sign. So if 6 is greater than or equal to v, then v is less than or equal to 6. And when a question asks you to simplify your answer as much as possible, I would consider making the variable part of the subject of the equation on the left-hand side a part of that simplify process. So that's something that I would prefer to see you do anytime you solve an inequality. If your variable ends up on the right-hand side of the inequality sign, flip it around so the variable's on the left. That way, when we read this inequality, we read it as the sentence v is less than or equal to 6, which tells us what we want to know about v. Okay. So the good news about solving an inequality is that all of our steps up to this point, same steps as for solving an equation. As for an equation. I'm going to break that rule just a little bit in our second example. Some of you might know why already, but At least in this example, it was exactly the same steps as for an equation. Just making sure that our variable ends up on the left side at the end of the problem. But I don't want to stop there with this problem. I want to think about how we can understand what the meaning of this inequality is that we got as a solution in a couple of different ways. So first of all, if we wanted to visualize this solution on a graph, on a number line, what kind of a picture could we draw to convey the information that the v's which solve this inequality are those v's which are less than or equal to 6? What ideas do you have on how we could create a picture on this number line that indicates that?
Put a
Yeah,
solid
sure.
dot on 6.
Okay, so somewhere on this number line is the number 6. It didn't come pre-labeled, so we can sort of put it wherever we want to. Let's say that 6 is right there. So, Jordan, you're saying put a solid dot right there.
Yes, because it's less than or equal to.
Okay, so this is the first thing we observe about how this process of creating a diagram works. Whoops. Is that I'm going to put a dot here at 6, and I'm going to make it a solid circle. It's filled in. And you're telling me that the reason we fill in that circle is because we want the number 6 to be a part of this solution. So 6 is included in our solution. In other words, if we try to put in a 6 for v down here at the bottom of this statement, we get a true statement. 6 is, in fact, less than or equal to 6. Less than or equal to 6. Yes. So it's that or equal to piece that convinces us that 6 needs to have a solid dot on top of it. It's what we call a closed interval that we come up with for a solution. So we have a solid dot at 6. But 6 is not the only number which solves this inequality. What other numbers also solve this inequality? Anything less than 6. So 5 does, 0 does, negative 10 does, 1.3 does, pi does, all kinds of numbers. Any number that's real and which is less than 6 also solves this inequality. So how do we indicate that on the graph? What do we have to add? Yeah. Shade everything on the number line which lies to the left of 6. And that diagram now represents the entirety of possible solutions to this inequality. So here are all the v's that are less than 6. They lie to the left of 6 on the number line. That's what less than means. And then 6 itself is included, so we close our interval on the right-hand side with a filled-in circle. So there's a graphical depiction. And my recommendation is whenever you solve an inequality, whether it's asked for explicitly or not, sketch that graph. So first, find what is the solution as an inequality. But then second, before you do anything else, sketch it on a number line. Because now that it's on a number line, we can take the next step, the third step, and fill in this last and most problematic form of communication. How can I write this solution using an interval? What does that even mean? What kind of information do we need to specify an interval, a subset of the real number line, which may have a lower bound, it may have an upper bound, it may include that lower bound, it may include that upper bound. How do we write this in an interval notation? I'm using a lot of words that maybe our math majors know by the time they're juniors and seniors, but which don't often get used in this context, like upper bound, lower bound, da, da, da. So let's talk about interval notation for a minute. When we say to express your answer as an interval, what we want to know is really asking the question, how far does this answer extend on the number line to the left? And how far does this answer extend on the number line to the right? What is the lowermost point that's a part of this interval? And what is the uppermost point that's a part of this interval? Let's start with the uppermost point. What is the uppermost point of this interval which solves our inequality?
6.
6. So that's an easy thing to answer, right? 6 is the, let's call it the highest point. And before we do anything else, I want to ask, are we including 6? Is 6 itself a solution? Is it a part of our set or not? It is a part of our set. And so we have a specialized piece of notation that we use to indicate that. We'll put a square bracket next to the 6. So this square bracket says that we're including 6. Includes 6 itself. So we can actually trace the through line in our communication so far. We had a square bracket here because we had a closed circle in our graph up here on the top, And we had that because we had less than or equal to in our original inequality. So those things all occur together. A less than or equal to turns it into a closed circle, turns into a square bracket in interval notation. So if that's the highest point in my interval, what's my lowest point? How far to the left on the number line does our solution go? What is the least number that solves our inequality?
Forever.
It goes on forever. There is no least number. No matter how far to the left on the number line we go, we can always keep going further to the left and still have more solutions over there. So we need a way to indicate that. How do we indicate that this interval goes on forever toward the left on the number line?
Infinity.
Infinity. So the infinity indicates that we don't stop at a finite number, we keep going all the way out to the horizon. Infinity written just like this tends to indicate infinity on the positive end of the number line. We want infinity on the left end of the number line. So how do I write that? Let's put a negative sign. Make it a negative infinity. Exactly. So this negative infinity here means that there is no lowest point. Make sure in your interval notation that the number which you put on the left side of your interval and the number you put on your right side of your interval really are leftmost on the number line, rightmost on the number line. We wouldn't put negative infinity on the right side, for example. But negative infinity being on the left side of the number line, it can be the left bound on an interval. Okay? I'm going to put a comma in between my lowest point and highest point. That's a part of the interval notation as well. And the last thing we need to know is, what about negative infinity itself? Is it a solution of this inequality? Can I plug in negative infinity for v and get a true statement here?
Say no.
Why not?
It's not one number.
Because it's not one number. Infinity is a slippery thing. It's a slippery entity. It's not a number. And because it's not a number, we can't plug it into anything at all and get a reasonable answer. So what we want here is a symbol that indicates that we're not including negative infinity as part of our solution. So if I used a square bracket when we did include one of the endpoints, what should I use for when we don't include an endpoint?
Yeah.
The other kind of bracket, yeah, a round parenthesis, yeah. So we'll put a round parenthesis here. That means not included. So not including negative infinity. And negative infinity, positive infinity, those never get included in solutions, ever in interval notation in an algebra class. Even our math majors, I think, never actually use infinity as a number. There's, I think, one course in the math major where you can get away with it. It's complex variables, 417. Most math majors don't even take it. I love the class, but infinity is never treated as a number unless you get special permission to do so as a math major. So the quick and dirty for us is any infinity we have in our solution is always going to have a round parenthesis next to it, whether it's negative infinity as it was here, or whether it's positive infinity as it might be in a different problem. So if I clear away all of the annotation here, the interval that we would write that conveys the solution of this inequality is the interval from negative infinity to 6, including 6, but not including negative infinity.